Ever looked up at the night sky and wondered why satellites don't fall down? This question has puzzled people for centuries. The answer lies in a delicate balance between two basic forces, speed and gravity. We know that gravity is the force that pulls everything towards each other. It's what keeps us grounded on Earth. And yes, this force is also pulling on the satellites orbiting our planet. So why don't they fall down to Earth due to gravity? Friends, the answer is speed. Satellites are sent into space at very high speeds. This speed is so high that it balances the force of gravity. It's like a cosmic tug-of-war, where speed and gravity are always fighting each other. For example, GPS satellites, the Hubble Space Telescope, and the International Space Station all work on this principle. Knowing this gives us a strange sense of joy and wonder about how all these things are floating above us. Imagine you throw a ball straight up. What will happen? It will go up, slow down, stop for a moment, and then come back down to the ground. We all know this happens because of gravity. Earth's gravity is always pulling on the ball, making it slow down as it goes up and speed up as it comes down. Now imagine if you could throw that ball very fast, so fast that as it falls towards the Earth, it also moves very quickly horizontally. The ball will still fall because of gravity, but its forward speed will be so high that it keeps missing the Earth as it falls. This is what happens with satellites. Gravity is always pulling them towards Earth, but their high speed keeps them from crashing into the planet. It's like a cosmic throwing a ball, where satellites are constantly dodging Earth's gravity in a special way. The balance of gravity and speed creates an orbit. An orbit is not a straight path around the Earth. It is actually a curved path, a constant free fall towards Earth that never hits the ground. Think of it like this. Imagine you are on a roller coaster, and you reach the top of a big loop. As you go over the edge, you feel weightless, like you are falling, because you are falling. But the roller coaster track is curved in a way that redirects your downward momentum, keeping you from falling straight down. The same thing happens with satellites. They are constantly falling towards Earth, but their forward momentum and the curve of their orbit keep them from crashing into the planet. It is a beautiful and complex dance of gravity and speed, showing the beauty of the rules that govern our universe. Chapter 4, Falling Around Earth. A different view on satellite motion. So to answer the initial question, why don't satellites fall to Earth? Actually, they are falling, but they are falling in a special way. They are falling around Earth. This constant freefall helps satellites stay in orbit and perform many tasks, from communication and navigation to weather forecasting and scientific observation. They are continuously orbiting our planet, easily ignoring the relentless pull of gravity while diligently completing their missions. But here's the thing, not just any speed will work. The farther a satellite is from Earth, the weaker the pull of gravity. This means that satellites orbiting at higher altitudes don't need to move as fast to stay in orbit. Chapter 5, Satellites, the unsung heroes of the modern world. Satellites have become essential for our modern lifestyle. They connect us, give us information, and help us understand our planet and the universe around us. And all this is possible because of a delicate balance between two basic forces, speed and gravity. So next time you look up at the night sky and see tiny points of light, remember they are not just stars. They are complex machines, trapped in an endless dance with gravity, quietly working to make life on Earth a bit easier, more connected, and much more interesting. Now a question to think about. If gravity suddenly disappeared, what do you think would happen to all the satellites orbiting our planet? Share your thoughts in the comment section below.